Okay, for the last unit here in Unit 5, we're going to be looking at derivatives and integrals of inverse trig functions. You've all seen this notation before for inverse, sine, cosine, and tangent, and what that's used to do is if you have a right triangle and you know two sides of it, you can use inverse to solve for that missing angle there. This notation also means inverse, sine, cosine, and tangent, arc sine, arc cosine, and arc tangent. And as you get into higher level math, they use that more because it starts being questionable whether that notation on the left, does this mean inverse tangent, or does it mean tangent of x to the negative first power, which could also be written as in that same notation. So because we don't know which one it might be or which one it's talking about, this notation tends to be used more as you go past calculus. All right, what are the derivatives of these functions? Derivative of inverse sine is 1 over the square root of 1 minus whatever you're taking the inverse sine of squared. Cosine, exact same thing, but negative. Inverse secant is 1 over whatever you're taking the inverse secant of times the square root of that same thing squared minus 1. Cosecant, again, being same but negative. And then finally we have tangent and cotangent, which are also similar. Inverse tangent is 1 over 1 plus whatever you're taking the inverse tangent of squared. Cotangent, same but negative. So what we're going to do is look at some of these derivatives now. What is the inverse sine, or derivative of inverse sine of something squared? So we just had up on the screen that if you are finding the inverse sine here of something squared, that would equal 1 over square root of 1 minus whatever that is squared. That's the derivative of that. We are going to be doing that same thing. However, this is an x, it's x squared. So what we're going to have to do here is chain rule as well while doing this derivative. And so our derivative here will end up being derivative of the outside function, which is the inverse sine, which is going to be 1 over the square root of 1 minus whatever we're taking the inverse sine of squared, which in this case is x squared, times, and this is where chain rule comes in, what is the derivative now of x squared? It would be 2x. So now to simplify that, it would just be, we could multiply these two together. So 1 times 2x would be 2x all over the square root of 1 minus x squared. Squared is going to be x to the 4th power. And so that would be the derivative right there. Okay, next, let's try another derivative here. This one is arc cosecant. Again, looks like we're going to have to do chain rule here because we got an inside function. So if you look at what derivative, if we look back at what derivative of cosecant is, we see that it is negative 1 over whatever we're taking the cosecant of times the square root of that squared minus 1. So coming back to this problem, our derivative here is going to be this. So wherever we have that x is where we're going to want to substitute it. So our derivative here is going to be opposite of 1 over whatever we're taking the inverse cosecant of times that same thing squared minus 1 times, again, chain rule. Okay, this is where the chain rule comes in. What is the derivative of 1 minus 2x? It'd be negative 2. So now multiplying this together here, these two negatives are going to make this positive, and 1 times 2 would mean we got a 2 on top. on bottom here, I am going to multiply this 1 minus 2x squared out. So if we multiplied two of those, we'd end up with 1 minus 2x minus another 2x plus 4x squared. Simplifying that, we get 1 minus 4x plus 4x squared. But then we got this other minus 1 that's still there from up here. It looks like then these two ones cancel out. So now our derivative would become 2 over this. I just switched those two terms around, which is fine because they're being added or subtracted. Last thing here, there is one more simplifying thing we could do on this. Because both of these two terms have a 4, we could factor that out. And the reason that would be okay, or we'd want to do that here, is because if we factored out that 4, we can use square root properties and say that's going to be the same as square root of 4 times the square root of x squared minus x. Square root of 4 we know is 2, and so these would cancel out. And so the final derivative here would be 1 over this. And that's how you'd see the answer if you were checking like a textbook type answer or question. All right, why don't you pause the video and try this one and see if you can come up with this derivative. All right, let's see what you got. Again, this is going to be chain rule here. Derivative of inverse tangent is 1 over 1 plus whatever you're taking the tangent of squared, but we got to do chain rule, so times 2 here because the derivative of the inside part's 2. Simplifying that, would be 2 over 1 plus. I am going to multiply this out again. It would be 4x squared plus 4x plus 1. Simplifying, we could add those two ones together. And then finally, it looks like all these terms are divisible by a 2. And so final simplified answer would look something like this. So that would be a simplified answer derivative for this one. All right, so we've done some derivatives. Now let's look at antiderivatives. So if we're doing antiderivatives, all those derivatives we just looked at, if you were taking the integral of one of those forms, the antiderivative would be one of these inverse trig functions. So let's try one of these out here. We want to evaluate this integral. If you notice, this looks like the form we had a second ago when we were doing this inverse tangent one down here. And so the antiderivative of this is going to be inverse tangent. And so antiderivative is inverse tangent of x. Now we want to evaluate it at 1 and negative 1. So we're going to have to do what's inverse tangent of 1 minus inverse tangent of negative 1. So now let's jump on the calculator and see what we get here. So if we do inverse tangent here of 1, we get this. Now that doesn't look like an exact answer like we need to answer with on the exams, but you got to remember, inverse tangent finds angles. Our angle here is in radians, so that means our angle includes pi in it. So this, if we divide out the pi that's part of this, we should get hopefully an answer that is an exact answer, and we see that the remaining part after dividing out pi is 0.25 or 1/4. So that tells us inverse tangent of 1 is pi over 4. We can do the same thing now with the other one, inverse tangent of negative 1. And we see that we get the exact same thing, but negative, so this is telling us that this is going to come out to be negative pi over 4. Adding those together, then we get 2 pi over 4 or pi over 2. And so the exact area under this graph from negative 1 to 1 is pi over 2. Okay, let's have you guys try this one. So pause the video and see what you come up with. Okay, Let's see what you got. This one, if you notice, is the form of inverse cosine here. Remember, if you get a dx right in here, we could also write it here and place a 1 there, and then you can see that is the same. So this antiderivative is inverse cosine of x. We want to evaluate that at 1 and 0. I'm putting that in. You get cosine inverse of 1 minus cosine inverse of 0. On the calculator doing those here, inverse cosine 1 is 0. Inverse cosine of 0. You get this, which if we divide by pi, gives us the fraction of 0.5 or 1/2, and so this is pi over 2. And so the answer for this one would be negative pi over 2, which tells us most of this area on this graph is probably underneath the x-axis that it came out negative. Okay, let's try another one here. So this one we want to find antiderivative of this. Now if you look at all the antiderivatives, none of them have here, they're all squared here. If you notice, every one has a squared term here. So what we have to do on this problem is figure out what exactly is being squared here. So what right here is being squared? Well, the term that's being squared there is 4x. If you take 4x times another 4x, you get 16x squared. And so that's the term being squared in our problem. To get the antiderivative of this, though, we want to now use a substitution here and substitute in u in for 4x so that we can find this antiderivative a little bit easier. But that also means our derivative here is 4dx, or when we substitute this in, there's going to be an extra 1/4 here. So let's make that substitution now. So if we substitute, we get 1 over x. This is going to become u squared minus 1. If we substitute in for dx, this is going to be du with the 1/4 on here. So last thing now, we still got this last remaining u or x that we got to substitute in for, but we know now how to do these. We want to play around with this to get what x is. So x would equal, if we divide that to the other side, 1/4 u. So in place of that x, we're going to substitute in 1/4 u. Okay, that 1/4 is in the denominator. So if we multiplied by the reciprocal, that would mean that really this is the same as having 4 up here if we multiplied by the reciprocal. And then we can see that those two 4's cancel out. And so our antiderivative comes out to be this, which looks exactly like the one we had there for inverse secant. And so this is going to be inverse secant of u plus, there could be some constant. This is an indefinite integral. And then the last thing we need to do on these indefinite integrals is substitute back in for our substitution for u here, which we did 4x. And so the antiderivative is inverse secant of 4x plus c. Let's try another one. This one, again, we got to figure out what is being squared here. So first thing we want to do is rewrite this as 1 minus, that would be x cubed being squared. So that's going to be what we want to substitute for. We're going to put u equal to, try that again, u equal to x cubed, which means if we take derivative here, it's going to be 3x squared. So we can see this 3x squared dx is going to turn into our du. This is going to be our u here. So substituting, we're going to end up with 1 over the square root of 1 minus u squared du. And that is inverse sine. And so antiderivative is inverse sine of u plus c. Now we got to substitute back in, and so final answer is inverse sine of x cubed plus c. All right, I'm going to pause the video and try this one again. Start with trying to figure out what here is being squared. All right, let's see what you got. This 8 is a constant you can pull out. This would be 5x being squared. And so that's what the substitution you'd want to do is put u equal to 5x. Derivative then being 5 dx. And we don't have a 5 there, so let's divide it to the other side. When we substitute in, there's going to be an extra 1/5. I'm going to put that extra 1/5 out here and multiply it, so it'd be 8/5. And then we'd have 1 over 1 plus u squared. This is the antiderivative of inverse tangent. Plus, we could have some constant on here, and then final answer we want to now substitute back in. And so our final answer that hopefully you got was 8/5 times the inverse tangent of 5x, because that's what we substituted for, plus a possible constant. All right, the last ones we're going to look at are, again, we don't have anything squared. Also, this is new. This one's new because we got a term here that's not 1. If we look back at these antiderivatives, all of them in having a term squared also have 1 in here. And so we need that to be 1 to try to find this antiderivative. And we got to figure out what's being squared. So the first thing we got to do on these ones is factor out whatever we need to make this 1. So on this one, we want to factor out a 25. And so we're going to factor out a 25 here and figure out what's left over. So if we factored out 25, the first term would be 1, because 25 divided by 25 is 1. Plus, this would be e to the 6x over 25 then. So that if we were to distribute that 25 back out, we would get what we started with. All right. I'm going to pull that out as a 1/25 here. And then the other thing, just like the problems we just did, we have to now figure out what's being squared here. So if we look back at what we just had before, we can see that on the bottom, 5 is being squared. On the top, that would be e to the 3x, so that if we times it with the squared, we'd get e to the 6x. So this is now what we want to do our substitution with. Our substitution is going to be e to the 3x over 5. And now we'll find our derivative. To find derivative of this, we should maybe first think of this a little bit different. We know we could also think of this as 1/5 e to the 3x. This derivative does have chain rule here. So derivative of the outside is the exact same thing when you have an exponential, but we get to take derivative of the 3x, which is 3. And so moving this stuff to the other side to solve for dx, this is like a 3/5, so we'd have a 5/3, and there would be a e to the 3x on the bottom if we multiply by the reciprocal there. And so substituting in now, there's going to be this extra 5/3. This is going to be 1 plus u squared. We also have this du over e to the 3x, and we can see these e to the 3x's cancel out. So simplifying one more time, we can simplify this to 1 over 5, and so we got a 1/15 out here. Here we got 1 over 1 plus u squared du, And now we can see that that's one we know. That's antiderivative for inverse tangent. Plus C, we got this constant of 1/15. Finally substituting back in. Here, our substitution was e to the 3x over 5. And so final antiderivative here is this. So that would be the antiderivative of this one. All right, one more. Let's have you try this one. Again, goal to start with is try to get this to be 1 and figure out what's being cubed. All right, let's see what you came up with. Again, I'm going to pull this 8 out. That's just a constant. We're going to have to divide here by, or factor out a 36. And so this is going to be 1 minus x squared over 36 dx. So we want to figure out what is being squared there. Also, we can take advantage of square root properties and split this up as 2 square roots. Okay, what is being squared there? Well, we can see on top it's an x, on bottom it's a 6. And so that's what we want our substitution to be. We want to substitute in for u in for x over 6. Derivative of that being 1/6. And so if we solve for dx, that's going to make this 6 du. All right, so let's see what we got left now. Got that 8 out there. This we know is the same as 6. We got square root of 1 minus u squared. In for dx, we got a 6 du. So it looks like these 6's cancel. So now we have 1 over square root of 1 minus u squared du. That is inverse sine. And so now we got 8 inverse sine of u plus c. And then substituting back in the x over 6, our final antiderivative is this. So that would be the inverse, or the antiderivative of that. All right, you're going to try some of these out now on your own.